lessons for an 8th grade math games class, so they go slow, we go over things a lot. Lessons that seem like it should be a day last 3 or 4. But so this is the second day, like I was saying. The first day we worked on the brain pop video, so they saw examples. They saw difference in elevation as examples of negative and subtracting. And so now we are doing just more examples of modeling and showing them, just like really showing them the concepts. So I'm gonna try. Okay, so I started off with a review. So you guys know what these words mean, so we can do the review, I think. So in your groups, just think aloud a definition of these 3 words. So you guys can come up with that for a second.
Positive and negative number. Positive or negative and positive. Whole numbers. There we go. So one word. So I have to go on the outside, so that makes it a living body on the inside. Or the word that you don't even know what's absolute. Positive value makes any number positive. Is it a distance to the number? It's like positive.
Okay, so now we'll just go over these as a class. They use the board a lot because like going up to the smart board, so we can do that. So who feels pretty confident in their definition about an integer? They would like to share it. Barrett?
It's any positive or negative number in 0, but it has to be a whole number.
Alright, let's see if you're right. Okay. So the numbers that are whole numbers, negative whole numbers, and 0. So that was perfect. Good job. Okay, so now we're going to decide if the following numbers are integers or not integers. So, who wants to volunteer for the first one? Alex.
Yes, it's an integer.
Let's see. Good job. Alright. Shara, what is that second number?
1/2.
1/2. And is that an integer or not?
No.
Very good. Alright, next one?
Yes.
Memo.
Yes.
Good job. And Dusty?
0 is an integer, yes.
Good job. What about this next one? Liang?
It's not in.
No. And why isn't it an integer?
There's a decimal.
Because it's a decimal, so it's not a whole number. Good job. Alright, so we'll do the next definition. So, I know you talked in your group, so who feels pretty confident about their definition of absolute value? Ben?
It's the distance of a number from 0 on the number line.
Yeah. Let's see. The distance from a number to 0. Good. And absolute value, can it be negative? Because distance is a negative. So, what are the absolute values of these? Larissa, what's the first one? 3. Wow. Michael, what's the second one?
7.
Okay. Carl, what's the third one?
It's 100.
Awesome. And Jody, what's the last one? 100. So why do these last two, why do they have the same absolute value? Can someone explain that? Barrett?
Because 100 is like 100 points away from 0, and negative 100 is 100 points away from 0 to the opposite
Yeah,
direction.
just the opposite direction. So if we had our number line, we could see the two, and they're the same distance from 0. Yeah. Alright. So additive inverse. Who wants to share their definition of additive inverse? Ian?
I'm guessing, like if you flip the number upside down and then add them, then it's inverse?
If you flip it,
Yeah.
so like if you have, so if I have 4, what would the inverse look like?
9.
Like 9, alright, I see what you're saying. Not quite, can anyone help him out? Lindsay?
It's, well, for 4, it'd be -4.
Okay, so we're looking for a number, and what do we have in common?
When you add them together, they equal 0.
Good, let's see. So the number you add to a number to get a sum of 0. Perfect. So what are the additive inverses of these numbers? Dusty, do you know what the first one is? Perfect. Alex, what's the second?
13.
Okay. Memo, what's the third one? 9,000? And Cheryl, what's the last one?
-47.
Good job. Okay, so we will do the. Alright, so we'll do the beginning of this problem. So you all have your chips on the board, or on your tables. On the board we're going to have black and red just because in the classroom they have black and red ones, but here we're going to use black and white, so we'll just pretend white is red for this case. So our black chips are going to be our positive numbers. And in this case our white will be the negative. So each of your chips represents one. So each of the black will be representative of one and our white's negative one. So let's see the example of what we're going to do. So we'll watch this, and we're going to model. So your problem here is -8 plus 5. So you see how they're modeling these chips. So that's how they got the -8 here. And then they're adding in the 5 black ones. So if you see, they paired them up, and we have a 1 and a negative 1, so those are additive inverses, or as a teacher I'm observing with calls them 0 pairs. And so that's how you can tell that putting them together cancels it out. And then what you're left over with is our answer. So we have -3 left. So you can try one on your own, and then I think we'll be just about out of time. So try to model this with your chips. Black is positive. Just helping you out.
Michael, how have your experiences been with Katie's lessons so far?
Figured out how to do 7 plus negative 5. Using these chips.
So we're running out of time, but does someone want to come up and show me how they did it on their board? Well, Carl said 1 more minute, so. Alright, Dusty, do you want to show us really quick how you did it? You can just drag these in.
Sure. This one's the red and the negative, right? Reds. Split them up, and do 2 black left, so it's 2.
So it's +2. Does everyone agree with that? Let's see. Good job.